All right, this is the Your Turn on page, or section 8.2, and we're going to do problem number 1 in this video. This might be longer than 5 minutes this time around because I'm just going to do the whole problem number 1. So the first thing we need to do is find the factors of each of these numbers. So for 28, we have 1 and 28, and we have 2, and we have 14. And then for 3, no, 3 doesn't go into it. 4, yes, 4 and 7. 5, no. 6, no. So we know we've met ourselves in the middle. And then for 70, we're going to do the same thing. 1 and 70. And then 2, yes, 2 and 35. And 3, no. So 3, 4, 4, let's see, 4 will go in there. One time with 3 left over, so no. 5, yes, because it ends in a 0, so 5 goes into 70 once with 2 left over, so 14. And then we have 6, no. 7, yes, so 7 and 10. 8, no. 9, no, and so we've met ourselves in the middle. And then next we have 56, so 1 and 56. Don't forget, always make sure that you do 1 and the number itself. And then 56 is even, so 2, and 2 carry the 1, which is 8, so 28. And then 3, 5 and 6 is 11, so it's not divisible by 3. 4 goes into 5 one time with 1 left over, so yep, so 1 time with 1 left over, which would be 14. And then 5, no, because it doesn't end in a 5 or a 0. 6, 6 goes into there, no. 7, yes, 7 and 8. And so we know we've met ourselves in the middle because 7 and 8 are right next to one another. Now we're looking for the largest in common. So starting at the upper end, no 70 in common, no 56 in common. These two have 28 in common, but the 70 isn't divisible by 28. And so then we go down and we see 14. And so what we see is each of these should be divisible by 14. And you can always check that out and see if they are all divisible by 14, and if there's anything left over, then you know it's not correct. So 28 divided by 14, well, that's 2. And then 70 divided by 14, and that one's 5. Is that right? Let's see, 20, that's 5, yes. And then 56, and 56 divided by 14, and let's see, that would be 4, right? And so now, looking at these numbers here, right, they were all evenly divisible, and these numbers here, is there anything left in common? Nope. So we know we did indeed get the greatest common factor. So the greatest common factor is 14, and that's how you can check yourself. First of all, evenly divisible. Second of all, the quotients of those would no longer have anything in common. All right, moving on to our second one here. When we just have variables, we're looking for the lowest exponent. So we have exponents of 2, 1, and 3. Lowest one is 1, so that's our GCF. And again, you can check yourself by seeing if they're all evenly divisible by that, and then after we divide it out, if there's anything left in common, right? So x squared divided by x, that equals an x. And then an x divided by an x, yep, that's evenly divisible, and it's just equal to 1. And then x cubed, and divisible by x, and that gives us an x squared. And there we have x squared, and 1 and an x, nothing left in common, all evenly divisible, so we have a check that that is indeed our GCF. Now, when we're looking across here, we're looking at numbers and variables, so the lowest factor here, 3, is actually a factor of all the numbers, so we know that that is the GCF of those. And so down there in blue, you'll note that I have written that when the smallest number is a factor of all of the other numbers, it's going to be the GCF. So that's a 3, and then the lowest exponent on the x's is squared, so 3x squared is our GCF. And again, you could check that and see if they're evenly divisible, and then if there's anything left over. All right, now looking at our next one here on our variables, we see there's no numbers in common because there's no numbers here, so there's no numeric GCF. Looking at the variables, we have x's, x squared, x first, so the GCF in the x portion is x. And then we have a y cubed, a y squared, but this one doesn't have a y. and that means that y cannot be a part of the GCF. Remember that when a term doesn't contain a variable, then that variable isn't a part of the GCF. So our GCF is simply just an x, and you can see that those are all divisible by x, and then there would still be nothing in common all the way across. Okay, moving on to our next one, we have the 12 and x y squared, and we have 20x squared y cubed, and then we have 24x cubed y squared. So looking at the variables on each of these, we see that the GCF is going to hold for us an x in each case. So x, and then the y here, y cubed here, y squared here, so it's also going to have a y. And then looking across at 12, 20, and 24, we can either do the same thing that we did on part A, or we can say, oh, we know that 4 in common, right? Because 4 out of here leaves us a 3, 4 out of here leaves us a 5, 4 out of here leaves us a 6, and then there's nothing in common all the way across. So 4 like that. And that's kind of the eyeball method, but remember, if we have to, we can always fall back to the factors of these things. 1, 2, 3, 4, 6, and 12 for 12. 1, 2, 4, 5, 10, 20 for 20, and I am thinking in my head the back and forth. I'm just not sharing that with you. And 1 and 2 and 3 and 4 and 6 and 8 and 12 and 24. And now looking across down from the top, no 24s, 12's in common there and there, but not here. Nothing in common, 6 and 6 in common, but not here. And then we see the 4, 4, 4, and 4, and there's the long and the short of why the 4 is the GCF. All right, that finishes one. Next video will be problem number 2.